Hey everybody, let's look at this one here. This is 11C, which is lab experiment force versus distance. It says a constant force F on a dart of mass m in the horizontal, a constant force F is exerted on a dart of mass m in the horizontal direction as it moves through a tube of length L. The tube is situated at a height h above the ground. Upon exiting the tube, the dart travels a horizontal distance x before striking the ground as depicted in the diagram below here. So the first thing is it says the supposed students experiment with the tube in a variety of darts. Some darts have higher masses than others, but they're all basically the same otherwise, assuming air resistance is negligible, so we can avoid that. Should the students use a dart with a large mass or a small mass to launch the dart the farthest distance possible? Well, I think the intuitive idea is pretty small, or pretty correct, which is that it is the small one here. So the small mass will make it go further. So why? Well, Newton's second law says that acceleration is inversely proportional to the mass. So what that basically means is as our mass drops, our acceleration goes up there. If our acceleration goes up for a given distance, then our final velocity will also go up there. So that means we'll exit with the greatest velocity for the smallest mass. Now, after you leave, all of these darts, regardless of mass, will have the same height above the ground. They'll have the same gravity pulling them down, so they'll be in the air for the same amount of time there. So that means that none of that matters. So the distance you go sideways is merely proportional to the velocity that you leave with. So that means that as your velocity goes up, your distance you go sideways goes up. So in the end, again, more or less mass, greater velocity you exit with, greater distance that you travel there. Then they say, a student finds this equation on the internet. Does this agree with what you were just saying? No, it does not. The reason for that is right here. According to this equation, the distance you travel is proportional to the mass. So what this is basically saying is if our mass went down, then our distance sideways would also go down, which is not what we just said there. Then they say another student finds this equation on the internet. Is this equation reasonable? Forget what we were just arguing about. And so no, this equation is not reasonable for two reasons. One, it says that the distance is proportional to gravity. So in other words, if you went to a planet with higher gravity, it's saying that you would go farther to the side. We know that's not true. It'd pull you down faster there. Look at this too. It's also saying that the distance that goes sideways is inversely proportional to the length of the tube. But if the tube is longer, then what this is saying is that your distance that you would travel would be less. But a longer tube would push longer on the dart and make it accelerate more. Or you could say it's got more of an impulse because it'd be in the tube for more time. Or you could say it does more work because it would be pushing it on a further distance. Any way you look at it, a longer tube means a greater velocity, and so you should go a further distance there. All right, so now this part gets to be a bit of a mathematical mess here. They say they find this equation right here, and they would like to do right here what they say linear regression analysis. So in other words, that marker doesn't really work. They want to make a graph, a straight line graph here. So how are we going to do this? Well, it says that we are able to, so the students are able to change the force, but not the length of the tube. So that means L's got to be constant, but we can change F, and we're going to measure how far the distance stretches, or the different distances they go there. So what I'm going to do, we're going to have to rearrange this. They're being real jerks here. Normally they give it to us ready to go. We're going to have to do a slight rearrangement here. So I'm going to move the F up here, and I'm going to move the H down there. So I'm going to write it like this. F is equal to mass times gravity over 4LH times x squared. And the reason I wrote the x squared out here is I'm going to make this look like a y equals mx. And there's no plus b because we don't have a y-intercept. So I'm going to put force on my y. I'm going to put the distance traveled squared on my x-axis. And then all of this stuff right here will be my slope right there. By the way, you could also solve this like this. You could say that the distance squared is equal to 4 times the length times the height over mass times gravity times force. So you could have solved it that way as well and put x squared on the y and force on the x. One nice thing about it that way actually is that the height will be all the way already up in the numerator there. Okay, so I'm going to graph force again on my y and the distance it traveled squared on my x. So when we get to this one right here, they give us a graph of the force, that's my y, and then horizontal distance. Well, that's not quite what I want to put on my x. I want to put x squared on there. So I went ahead and did this math right here. This squared becomes 12.3. This becomes 30.3. This becomes 49. This becomes 74. This becomes 104. And this becomes 123.2. So again, lots of times you'll see that on these design and experiment ones where they give you a blank line, and lots of times that goes with making a graph where you'll have to use the data to get yourself a new variable. So I just created x squared is my new variable right there. All right, so next thing they do is they want you to graph it and create a grid. Now that would take me a while to do on camera here, so I went ahead and I made one right here. So I scaled it properly. They'd like to see it take up more than half the graph. Make sure you label what goes on each axis with the units. So over here, actually, those should be switched. X squared should not be in parentheses and meter squared should be parentheses. But I made this nice little graph here that takes up more than half the space here. And I put a line of best fit on it. Remember, you can bring a calculator to, or sorry, you can bring a calculator, but you can also bring a ruler to the AP exam. So we've got that graph there. The next thing now they want you to do is they say, from the graph, determine the height of the tube given the mass of the dart is 0.02 and the length of the tube is 0.35. Well, let me come back to this real fast and write this down. Remember I said all of this is my slope. So I'm going to have to find my slope first. So m here is going to stand for slope, not for mass. Remember, slope is the change in the y over the change in the x. So one thing they would like to see you do is not necessarily use these data points, but find points that are on the line. And so if I find a couple good ones right here that look like they cross right at grids, this point right here, and then also it looks like, let's see here, this point right here. So when I go to solve for this now, I'm going to use those 2 points to get the slope. Remember, slope is the change in the y over your x. So if I look on this graph here and read it off, my final y point is 1.3. My initial y point is 0.3. So I'll go over there, and then if I look on here, in terms of my x, my final x point is 80, and my initial x point is 20. So if I subtract those, I get 1 over 60 is my slope. So now, let's bring this back here again. This is my slope, mg over 4LH. So let me write that down. mg over 4LH is equal to this slope right here, 1 over 60. This m is mass, by the way. So now I'm going to have to solve for the height. So I'll just rearrange this. Height will equal then. I'll multiply this over here, and I'll multiply 1/60th over there. So we get 60 times mass times gravity over 4L. And now I'm ready to simply plug in for there. So 60, the mass is 0.02 kilograms. The gravity I'll just use as 10. 4 is a constant, and the length they said is 0.35. And so if I plug all of those in there, I get an answer of about 8 I forget exactly what this comes out to be. It's 8.75, I think I got. Let me check that real fast. I left it on the calculator in the front of the room. 8.57. I got it backwards. So I got a value here of 8.57. So the height that I shot this from is 8.57 meters. That's tall. That's like, 24 feet around there. Anyway, that is how you do 11C.